This presentation aims to give a general overview about how the decision supports that have been developed under the AF3 project work together with the AF3 system. So the decision support subsystem offers web and mobile solutions for enhancing the decision making by a set of tools that allows introducing additional information, resources, or spatial information during a fire by those commanders in the intervention area, incident command post, or even from a remote control room or coordination center, allowed to do so by the previously assigned permits and security setups. The subsystem collects and links spatial information from smoke plume forecasts with the distribution of crowds. This information is collected from the related AF3 subsystems in order to proceed with evacuation of people at risk in case there are. For this to happen, the DS subsystem consists of a set of mobile applications that exchange information with the web application Emercarto, a central system in communication with the C4I. The DS subsystem is built over a web application which is being developed over HTML5 and it is called Emercarto and which works as the main core application. And some additional tools for mobile devices, which are in particular EmerMap, Emera, Emercarto, and a fourth one called SLPT, which allows us to get a position of the firefighting resources. If we have a look to the functionality, then we can see how, thanks to the architecture and security management of the decision support subsystem, an scalable service supporting decisions at different levels can be provided. So according to the position and decision level of the commanders, web or mobile tools can be used, being the web application Emercarto the most suitable and complete tool for command and control rooms and coordination centers, as well as for incident command posts. The use of the HTML5 for developing the application makes it easily usable from any platform. And on the other hand, the utilities of the web application Emercarto are spread to the intervention area and fire responder teams' positions thanks to the mobile applications, allowing the section chiefs and the chiefs of the teams to provide and consume relevant information fully alienated to the ground truth. Concerning the integration in AF3 system, in the frame of the AF3, as decision support system, Emercarto communicates with the C4I through web services, as well as with the firefighting lab, weather and crowd system to inform the C4I of the presence of risks to the population. It also includes the exchange with the situation awareness implemented in order to enrich useful information to commanders. All the web services have been developed in accordance with the interface control document and the F3 architecture. And therefore, the decision support subsystem allows the chiefs of the units deployed in the emergency area to count on information about the firefighting commands of the C4I and thus being able to adapt the performance of their units, making it easier to plan escape routes or selecting or informing about safe places, appointing lookouts, etc. And to provide feedback about the constraints and or strengths for the performance of the different intervention alternatives, including spatial information about critical points and suitability of different attack methods, etc. And for the firefighting coordinators in the command and control room, in the C4I, it is possible to provide this commander with combined forecasts about the spreading of the smoke plume and the behavior of crowds located in the affected area in accordance with information obtained from the weather and crowd simulation modules, as well as feedback from the operational commanders deployed to the emergency area about the indication and suitability of the firefighting options according to the interpretation of the ground truth from on-field positions. So annotations, points of interest, and critical points can be edited and shared in real time. Here we can have a look to the main interface of Emercarto, um, including some background maps on the area that the Spanish trial took place in the region of León, in the location of Fontanos de Torrio. And what we can see here is the emergency area where the different firefighting resources intervened in order to cope with the crisis. And then we can have some mesocontours of different densities of the smoke at a particular time. And we can also see singular points which are related to meeting points mainly of the different firefighting resources, and some additional points which include multimedia files attached, like images or videos that can be watched in real time from the remote control rooms. In this second one, we have a different background map, which is not, in this case, it is not the image of the landscape, but one map from a different provider. And then we can also see different isocontours of the simulation of smoke and different sorts of firefighting resources. Some points of interest, which include a picture or a video, and we can also see some premises. In this case, they are the headquarters of the firefighting team, which is located in the location of La Robla, close to the area of interventions. In the interface, we can see as well some control lines and some other spatial references that are introduced from the field or from the incident command post by the firefighting manager or the chiefs of the different firefighting units. This is what we can see in this slide, together with some points including videos or pictures. We can see flames in some positions which are related to incidents that have been registered in the system. As we can see in this slide, the decision support subsystem has had participation in the exercises of the AF3 in the different trials in several of the episodes. This is an example of the episodes where the decision support system was used, in this case in the last trial in Ashkelon in Israel. So in the episode 2, a huge fire event was leveled, and the decision support was used for tracking the position of a forest agent. It was used also for the sending of images from the operations area through the mobile app Emercarto. It was used for the activation by the C4I of a request, so as to let the C4I retrieve the information collected in the decision support system. It was possible to visualize the fire simulation commissioned by the C4I to the firefighting lab, which was something done and completed in the own interface, graphic interface of the decision support subsystem, and the visualization of the map of distribution and damages done by the C4I to the risk analysis module. During the first attack, one of the teams used the DS mobile tools, EmerMap and Emercapture, and they introduced special references for the first attack, like special critical points, in particular access to intervention areas, routes, etc. And capture and send images from the field through Emercarto being displayed on Emercarto and the mobile apps. They were able to update the fire perimeter through the mobile app EmerMap by direct edition on the screen, and they included annotations concerning the plan of attack, the controls line, the fire perimeter, etc. For the activation of aerial firefighting forces, the coordination center manager requested the overall general data from the decision support subsystem, and he obtained from the C4I crisis management the information included by the firefighting units through EmerMap and displayed them on Emercarto and on the C4I. For the treatment of injured firefighting personnel, the intensity of the firefighters' effort is monitorized through the app Firestress, which is displayed by the decision support system operator, triggering warnings in case dangerous thresholds are surpassed by some of the firefighters. So the decision support system operator can be aware at any moment of the situation of risk for these workers due to the work they are performing in the field and the intensity of the effort. The leader of the crew member monitors the intensity of effort of each member of the team in real time through the mobile application Firestress, and according to the displayed values, he is able to manage the shifts and the position of each worker. When the commander found out that the fire and smoke plume are approaching to a village, he may decide to handle the situation with parallel activity. So DS provides the areas with smoke concentrations and presence of human lives. It combines the result of the simulation distribution of people with the forecast of the smoke plume, and C4I gets the information. The use of DS tools to support decision of evacuation and make decisions on the use of preventive capsules is completed. CFRI retrieves recommendations from the DS subsystem by means of the web service DS General Data. In the episode 8 and 9, the DS tools are used for making decisions about the advanced strikes with the high drop system and the tracking of firefighting resources and return to base. So for this to happen, it is necessary to count on spatial references that are included in the system by means of direct addition by the commanders in the field. Going ahead with the different applications under the decision support subsystem, we can start to have a look to Emercarto, which is the main core web tool under this subsystem. If we have a look to the main home screen, we can find that it is composed of a map that can be changed between different map providers, and including the information and the different resources for the interpretation of the situation, and also spatial references entered through mobile applications, or also why not via the edition tools of the Emercarto application. On the right part of the screen, we have the different tools, such as the measurement tools, the queries, tracking, printing, etc., and changing of course, the maps, the background maps, and also we can activate or deactivate the different layers on the screen. We can use different filters on each of these layers in order to customize the kind of visualization we want. And on the bottom of the screen, we can find the different utilities for the management and edition and query of the alphanumerical information about the resources on display. Above, on top of the screen, there are the different menus that allows us to manage the different information and get some reports, etc., in order to get information, for example, of past events or about the situation some time ago, even in the same emergency. So, for example, in this slide, we can see that there are two mobile resources on display. They are assigned to an incident, and there is another incident, including a surface on a separate position at the west of the main incidents. And we can also have the different information related to one of the firefighting resources and the different labels that can be edited, including different attributes, etc. Using the Manage Main module, it is possible to edit mobile resources, incidents, single points, annotations, areas, multimedia, bases, water sources, lookouts, and different infrastructures. So here you can see, it is possible to see the properties of different firefighting mobile resources. The mobile app EmerMap, it's an application which enables positioning the emergency resources and means in a conventional map, see in detail its particularities, edit them, and even add new geo-referenced resources. This Android application for mobile devices also allows the user to operate offline in such a way that information is saved in the device so it can be used when phone coverage is lost, and automatically making use of areas with coverage in order to update information. The home screen includes some measurement tools and some visualization tools on the top of the screen in order to center the display in the current position or open the different layers and switch them on and off according to the visualization preferences of the user. It is possible to create new resources such as stations, special points, water resources, multimedia, events or incidents, points of interest, annotations, and event or incident areas. And also it is possible to include pictures or videos according to a particular position. In order to get this, EmerMap launches Emercarto app when uploading media files. It is possible to include annotations, allowing to edit on the map the linear spatial references such as control lines, and also events and incident areas, which are displayed as areas related to the annotation instead of longitude. In addition, measurements can be taken related to lines, to polygon surfaces or circular surfaces. The Emercarto application is a multimedia mobile app that is launched from EmerMap, but it can also be launched directly by the user, and which main functions are taking and making georeferenced photos and videos, sending files to the central repository in order to share them with other applications linked to Emercarto platform, automate file sending when a data coverage connection is established, selecting photos and videos stored in device memory, adding descriptions to the files, and saving media files in the device local memory, allowing displaying them at any time. It is an Android application for mobile devices that allows working without data coverage so that the information remains stored in the mobile device memory in order to share it automatically when the coverage is available again. So here there is the home screen of the application, and it is possible to see that each file counts on an alias for naming the multimedia file, a description field. It is possible to select between photo or video file from the local memory or to capture from the camera of the mobile device. It includes fields for latitude and longitude that can be automatically filled with the current position from the GPS, and it allows to save the media file to the central repository once it is completely edited. So it is possible to take the pictures and make videos, just taking into account that the resolution shouldn't be too high in order to make it easier the transferring of the files. The Firestress mobile app, it's a mobile app which is connected with the damage analysis of the forest fire responders, but it is linked as well to the Emercarto platform. So it's here explained as an additional and complementary software. The Firestress application, it's composed of Firestress web tool connected to the Firestress mobile app tool and to the sensors or the heart rate sensors that each member of the brigade wears. So for the heart rate recording, bands or wireless heart rate monitors will be placed on the lower chest area, and this will make use of real-time data transmission technology by means of ANT+ standard technology. There is an alert screen where the alerts can be displayed when staying longer than 1 minute continuously above the 100% of the theoretical maximum heart rate, when staying longer than 10 minutes continuously above the anaerobic threshold, when exceeding 200 beats per minute heart rate for longer than 5 seconds, when exceeding a total accumulated TRIMP, which is the workload, of 750, when staying more than the 25% of the total time in anaerobic conditions in periods of time from 4 hours up to 8 hours, and when staying more than the 50% of the total time in anaerobic conditions in periods of time under 4 hours. These alerts are fully configurable by pressing on the icon shown at the bottom of the screen. So here we can see the main screen of the mobile app, and on the Firestress all registered heart rate monitors are shown. There is a color code based on the work intensity. If it is gray colored, it means that the heart rate monitor is out of reach from the app coverage, which means that the data that are displayed are not updated. At the bottom of the screen, it is possible to find a button for initializing the heart rate recording, recording time, and the button for adding marks, which allows identifying the different tasks that the brigade members are carrying out during the firefighting, and in this way be able to synchronize the intensity effort values with the task that is being completed at the same time. Firestress web tool does have a configuration screen like in the app, and it allows to register new users and automatically calculate their aerobic and anaerobic threshold as well as their maximum theoretical heart rate. So it is possible to add new users, migrate data to Excel and PDF, and launch filters in order to do some queries. Within the configuration tab in the device management, it is possible to allocate an identifier to the user's heart monitor sensor. And again, it allows to insert devices and edit the properties of the devices and migrate the reports to Excel and PDF and do some filters. It is possible as well to manage the alerts in order to customize the thresholds and the values when an alert will be triggered. It's also again to migrate it to Excel and PDF and do some filters to search. There is an information screen which allows to display data sent from the mobile terminal, the sending time, the email number of the device, and the average of the data sent. Within the Information tab, in the Report Device Values, it is possible to display all the received data for each sending and for each user sort by minutes. Likewise, it allows to migrate all the information to Excel or PDF. Finally, we just have a look to the SLPT application, which is the application for positioning mobile resources involved in emergencies and disaster scenarios. This is not properly a decision support application, but it works together with all the Emercarto platform, so it might be convenient to have a look at it. It stores GPS coordinates and sends them to a central repository, so other applications can have real-time positioning of such devices. The home screen includes the starts and stops in positions button and a panic button, which allows the user to inform or that a request for relief is launched. It is also possible to open a drop-down menu, which includes all the settings of the application. So thank you very much. This is all for this brief introduction to the applications on the AF3 related to the DS subsystem. For further information, you can contact TRAGSA in the email address that is in this slide. And that's all. Thank you very much.